All right, let's do a video on transversals. So what we have here is that line P is the transversal. And so a transversal is a line that cuts across two other lines. So we have line M, line K, and then we have the transversal, line P. What you see is the transversal will form 8 different angles, and I've just pre-labeled these 1, 2, 3, 4, 5, 6, 7, 8. There's no real rhyme or reason where I started and the order in which I went. But you do want to know that it forms 8 different angles, and then we have 4 different vocabulary words that we want to describe. Okay, so we have and all of these are pairs, right? These are angle pairs. Angle pairs that are going on. Okay, so we have corresponding angles. Corresponding angles are angles in the same spot. Same spot. Okay, so if you think about this as a group of 4 and this is a group of 4, do you see how 1 and 5 are both in the top left? So 1 and 5 would be corresponding angles. Okay, 2 and 6 are in the top right. So 2 and 6 would be corresponding. 3 and 7 would be corresponding. They're in the bottom left. And then 4 and 8 would be corresponding. Okay. Alternate, exterior. Exterior means outside of the 2 lines, and alternate means to be on the opposite sides of the transversal. So 1 and 8, these 2 angles are on the opposite sides of the transversal, and they're exterior to the 2 lines. So 1 and 8 are alternate exteriors, and 2 and 7 are alternate exteriors. Okay, alternate interior, well, if you kind of understand what alternate exterior, then alternate interior would be alternate sides of the transversal and then inside. So 3 and 6 are alternate interior, and then 4 and 5. Okay, consecutive interior would be consecutive here. Boom, these 2 are consecutive, 3 and 5. So they're on the same side and they're interior, and then 4 and 6. Okay, so the vocab is very important. This is the transversal, and it cuts across 2 lines. It forms 8 angles. Those 8 angles all have different words that describe their relationships. Okay, corresponding angles are angles that are in the same spot, the same location relative to the transversal. In this case, like 1 and 5 are in the top left. Alternate exterior. Exterior means outside, and then alternate means on the opposite sides of the transversal. So 1 and 8. Alternate interior, alternate inside, all right, 3 and 6, and 4 and 5. And then consecutive, so like next to each other kind of, well, not next to each other because that's actually adjacent, but consecutive just means one and then the other, and they're both interior. So we have a group of interior here and a group of consecutive interiors there. Okay, these are true completely independent of how line M and line K are related, right? A transversal forms whether or not these are parallel. But we want to come over here and say, okay, if, this is a huge statement, right? If these 2 lines are parallel, and we can tell 2 lines are parallel because you can put like a double arrow here and a double arrow here, and then you know that those lines are parallel. So if you now know this picture, even though it might not look like line M and K are parallel because I just drew them without a ruler, if I label them like this, that means they're parallel. If they're parallel, then we can draw more conclusions. Then we can talk about, well, corresponding angles are actually congruent. Corresponding angles are congruent. Okay, so what I'm saying is that angle 1 is congruent to angle 5. But I'm also saying, and this should make sense, if angle 1 and angle 5 are the same, and angle 1 and angle 2 make a linear pair, and angle 5 and angle 6 make a linear pair, then doesn't it make sense that 2 and 6 also have to be the same? So like, those would be the same. okay? And then we can keep going because, well, isn't 1 and 4, aren't they vertical? You're like, well, that's an old relationship, right? That has nothing to do with the transversal, right? But 1 and 4 are vertical, but if 1 is congruent to 5, and 1 is also congruent to 4, but we know 8 and 5 are vertical, then don't we know 4 and 8 are congruent? You're like, oh yeah, they have to be because 4 and 8 are also congruent, right? All those sets of congruent angles are the same. Again, only if they're parallel. So 1 and 5, 2 and 6, 3 and 7, and 4 and 8, all of those would be congruent. 1 and 5 is congruent, 2 and 6 is congruent, 3 and 7 is congruent, 4 and 8 are congruent based on all that stuff. Okay? Okay, so if we know then that all the correspondings are congruent, we can start building other things. What do you think about the alternate exteriors? 1 and 8. You're like, oh, wait a second. 1 is congruent to 5 because they're corresponding, but 5 and 8 are vertical, so they're congruent. 1 congruent to 5, 5 congruent to 8. Well, then 1 must be congruent to 8. So we can conclude that alternate exteriors are also congruent if we have parallel lines. Okay, what about alternate interiors? Okay, so we're talking about 4 and 5. But 1 and 5 are congruent because they're corresponding, but 1 and 4 are vertical. So if 5 is congruent to 1 and 1 is congruent to 4, then don't 5 and 4 have to be congruent? You're like, yep. Alternate interiors are also congruent if lines are parallel. Okay, and then lastly, what about consecutive interior? Like, okay, consecutive interior, 3 and 5. What's the relationship there? You're like, well, 1 and 3 are a linear pair. Okay, so the measure of angle 1 plus the measure of angle 3 has to equal 180, and why? That was linear pair. And again, that has nothing to do with the transversal, right? That doesn't have to exist. We know that 1 plus 3 equals 180. Just like over here, we knew that 1 was congruent to 4, and that is completely independent, right? 1 and 4 are vertical. They're congruent. 1 and 3 are linear pairs. They're supplements. It has nothing to do with any of this down here. So let's go through this logic again. If 1 and 3 are supplements, but 1 and 5 are congruent, then don't 3 and 5 have to be supplements? You know, whatever measure 3 is, if 3 plus 1 is 180, but 1 and 5 are the same, then 3 plus 5 has to equal 180. So consecutive interiors are supplements, meaning they add up to 180. Okay, and so we could go through some numbers here. Let's say I make up a number and I say given, and I'll label it all in the picture. What if I told you that the measure of angle 1, what does that look like? Let's say 120 degrees. And you knew M was parallel to K, right? And that's all the information you had. If you know angle 1 is 120, let's maybe do that in a different color. What about green? Maybe we can see that. Okay. If you knew this was 120 degrees, then you already know that this is 60 because 1 and 2 are a linear pair. This is 120 because 1 and 4 are vertical, and then these two are vertical, so then that has to be 60. Again, I didn't even use anything about the transversal yet. I just used linear pair and vertical stuff. But now I'm going to go to this part. If we know they are parallel, then I know all the corresponding angles have to be congruent. 1 and 5 are congruent, so they have to be the same. But once you know that that's 120, that's 120 for 1,000 reasons, right? That's 120 because 4 and 8 are congruent. That's 120 because 1 and 8 are congruent. That's 120 because 5 and 8 are vertical. So we know, look at these three, corresponding, 4 and 8, alternate exterior, 1 and 8. Both of those ideas and the fact that they're vertical tell us that that's 120. But if those are 120, they all form linear pairs with these guys, they have to be 60. And hopefully you can see all of these things are true, including alternate interiors. 4 and 5 have to be the same. 3 and 6 have to be the same. When I say the same, I mean congruent, the same measure. And then consecutive interiors, check that out. 3 plus 5 equals 180. 4 plus 6 equals 180. And so we have all 4 of our facts. Again, these are only true if the lines are parallel. These names go no matter regardless. These are true always, right? Vertical and linear pair are always true. Okay, this will get you started on transversals and some of the vocab, reminding you that we have these old relationships of linear pair and vertical, and now we have new relationships, and then we have an extended relationship that if we know the lines are parallel, then we know these facts are true, and then we can do some problem solving. Okay, the next video on transversals, I'll do more problems with like solving for X and solving for Y given a transversal.